Rational numbers, chapter number 1 this is. And first let's start with the introduction. See, natural numbers which are counting numbers and starts from a 1 2 3 4 and so on. And whereas whole number which starts from the 0 with the natural numbers, as we know that natural numbers starts from 1 2 3, and in whole number only just 0 is including in this means that is natural numbers. Now the next one is that is integers. Integers means it will be, there will be 0 and there will be natural numbers will be there, but only what it is including here, it is including that is negative numbers. So it says that what it says in integers, that it says that negative of a natural numbers will be there, that is from 1 to 3, but it is having only negative signs with whole number. Again, whole number, that is nothing but from 0 and so on. So integers is nothing but negative of a natural numbers plus whole number. Okay. So now what is rational numbers? If p and q are the both integers, as we know that what is integers? Integers are negative natural numbers with a whole number. Okay, if p and q are the both integers where q is not equals to then p by q is called a rational numbers. It means p and q we are just writing in the fraction form, that is p by q, and here q is never it is going to be equal to 0. If it is q equals to 0, then we don't say this is a rational number. Okay, it should be not equals to 0. For example, I can take minus 3 by 7, here has been given in the textbook. Okay, similarly I can take 2 by 3, I can take minus 5 by 8. Okay, I can take minus, or I will just take plus 8 by 10, but it is not possible to write like this. So this is not a rational number here. Okay? Remember here some points we have to remember, that is 0 can be written as, so we can written in the numerator, but we never going to write in the denominator. If you written in the denominator, that is not a rational number. Okay, so from this we can say that 0 we can write in the numerator. In each case of these cases, denominator is not equals to 0. Okay, it means denominator, in the place of denominator we cannot write 0. So 0 can be expressed as a fraction with the non-zero. Fraction with the non-zero means 0 you can write in the numerator, and in the denominator you can write any other integers except 0. Okay, so that's why they are saying 0 is also rational number. Okay, now every natural number, every whole number, every integer and every fraction is a rational number. Every natural number we have studied, that is from starts from 1 2 3 and so on. Whole number starts from 0 1 2 3, and every integer, that is what, negative natural numbers plus whole number. Okay, and every fraction you can write any numbers in the fraction is a rational number. Only the remember thing is, in the denominator we cannot write a 0. Okay, so in the rational number p by q, where p and q are the integers, and as we know that q is not equals to 0, integer p is said to be numerator and integer q is said to be denominator. So this p is, we will say numerator, and q we will say that is denominator. Okay, for example, look at this example, minus 8 by 15, where minus 8 is a numerator and 15 is a denominator. And if the number, if anybody said that numerator 5 and the denominator is minus 2, we can just write in this form. Okay, a rational number is a positive if its a numerator and denominator have the same sign. See here, for example, they have given 5 by 8. As you can see in both positive, nothing it is there means there will be positive sign. Now look at the next example, it has been written that is minus 5 by minus 8. So both signs are same only. See, if a rational number is said to be positive when if it's a numerator and denominator have the same sign. In this case both signs were positive, and in this case both signs are negative. So what I can do, I can cancel this, and what I will get, that is 5 by 8. Again 5 by 8 is what, positive rational number only. Okay, so the next one is, whereas rational number is a negative, so when can the rational number can be negative? If its a numerator or denominator have the opposite signs. For example, I'll take the same example, if it is 5 by 8 and if it is 8 is having a negative charge, negative sign, so then we will say that it is a negative rational number. And if it is, I'll take minus 5 by 8, again this is a negative rational number. Why? Because it is having a opposite sign. Here it is negative and here it is positive. Okay, so some examples, more examples it has been given here. Okay, now let's discuss about if m is a non-zero integer and P and Q is a rational number, then we can say P and Q we can multiply with the M and M. See, let's take one example. In the place of P by Q, in the rational number, I'm just taking a 2 by 4, and in the place of M, I'm taking a 2 as a simple. So what they are saying, we can do multiplication with the numerator and the denominator. So after multiplying, what I'm getting, 2 2s are 4, here 4 2s 8, again 4 by 8. What is this? Is again this is a rational number only. And if the at the same time, if I'm dividing, okay, with the non-zero integer here at the numerator and denominator, 2 1s are 2 2s are 4. Okay, so again 1 by 2, what is this? Is a rational number. Okay, now this is what they are saying. If M is a non-zero integer and P by Q is again a rational number in case of multiplication or in case of a division also. Sixth, what is that? Let A by B and C by D are the two rational numbers such that A by B is equals to C by D. So when I'll do the cross multiplication, D goes to the left side in the form of multiplication, and whereas B goes to the right side in the form of multiplication. Earlier it was in the division form. So in place of A and B by CD, I am going to take a non-zero integer. So it will be, for example, I am just taking here, let me take 3 by 2 into which is equals to 2 by 4. Okay, it is like that. Now see here, what I'll do the cross multiplication. So as according to that, 4 goes to the left side, so it will become 3 into 4 is equals to 2, and this 2 goes to the right side, so it will become 2 into 2. Okay, now 3 4s are 12 is equals to 2 2s are 4. So again, this kind of a questions you will study in the exercise. And conversely, if they are given in the form of multiplication, what we can do, we can make it in a fraction. For example, I'm just taking this number only now. Okay, now just leave about this. What I can do now, 4 I'll shift to the right side. So when I'll shift to the right side, it is here in the multiplication relation. When it will go to the right side, it will comes in the division form. Okay, let 2 here and 1 2 I'm sending to the again right side, so again it will become in the form of division here. Now this side 3, let it be as. Okay, so this is conversely. Now seventh one, what it says, a rational number P by Q is said to be standard only when P and Q have a no common divisor, or we can say factors, then 1. And second point, Q should be positive. Q is, that is nothing but the number which is in the denominator, it should be positive. For example, we can take here 3 by 5. 3 5 is a rational number and which is in a standard form. Why? Because 3 and 5 we are not going to get any divisor for this except 1 here. And whereas that, look at this rational number 3 by minus 5, here minus 5 which is in the denominator, according to this standard form, what it says, Q should be positive. So what we can do, we can shift minus to the numerator, so it will become minus 3 by 5, again minus 3 by 5. This is standard form. Okay, now look at this third example. It is given minus 21 by 36, minus 21 by 36. And this is not a standard form. Why? Because 21 and divided by 3. At the time 36 also we can divide it by 3. And while we are doing, we must choose a same number for the numerator denominator. It's not like that here we can choose the 3 and we don't choose here 2. It should be both same. Now see here, 3 7s are 21. Minus, let it be as it is. Now here 3 1s are 3 2s are 6, that is 36. 3 12s are 36. Now as you can see here, minus 7. For minus 7 we don't have any divisor, but 12 we are having 2, but we can't apply. Why? Because at a time we have to divide for the 7 also, but we don't get here. Take another example, that is given 36 by 63. Okay, as you can see here 36, look at this number. As you can see here, 36 which is even number and 63 which is odd number. As we know that all the even numbers which exactly divide by always 2. Okay, but according to this theory, what we can apply only the same number for the numerator and denominator. Okay, since 36 comes in the 2 tables also, 3 tables also comes, and it comes in the 4 tables also. But what about 63, it doesn't comes in the 2's table, but it will comes in the 3's table. Okay, so let me apply a 3 for the both numerator and denominator. So here it is 3 divided by 3. Now see here, 3 1s are 3, 3 2s are 6, that is okay, 3 12s are 36, and here 3 2s are 6, 3 1s are okay, but here it is minus 1. So here now 21 and minus 21. So here we got, that is 12 by minus 21. Again, to write the standard form what we have studied in the second point, minus we should must shift to the numerator. So I'll get, that is minus 12 by 21. Now look at this number clearly. Further, still it is not in the standard form. Why? Because again 12 it can divide it by 3 and 21 also we can divide it by 3. Now see here, 3 4s are 12, minus let it be as it is. Now here 3 7s are 21. Now minus 4 by 7 is the standard form. Still 4 we can divide it by 2, but 7 we cannot divide by any number, only from the 1. So that is not possible. Okay, so here minus 4 by 7 is what? Standard form. Now we are going to study about the properties of addition of a rational number. First one is, that is closure property. So what it says, if two rational numbers are added together, the result is always a rational number. So if it means here it is, as you can see here, it is a two rational numbers are there, and if I added this, I'm going to get the answer which is also what? Rational number. So I'm just going to write here the paper, that is 3 by 4 and 5 by 6. To add this rational number, look at the denominator 4 and 6, which are the different numbers. So what we have to take? We have to take the LCM by short division method. Now always we have to start with the smallest prime number, which is a 2. Now 2 2s are 4, 2 3s are 6. Now still 2 it is there. Let me take 2, 2 1s are 2, 3 as it is. Now what left? Only 3 left. Now let me take 3, 3 1s are 3. Sorry, 1 as it is. Now 3 1s are 3. Now 3 is a 6, 6 2s are 12. So since we got the LCM, that is 12. Okay, now see here, 4 how much is a 12? 4 3s are 12. 6 how much is a 12? 6 2s are 12. Now what we have to do? We have to multiply here. 3 3s are 9 plus 5 2s are 10. Now 10 plus 9 is what? 19. So 19 by 12. So what they are saying, when the set of when two rational numbers we will add together, whatever the answers we are going to get, that is also what? Rational number. So since 19 by 12, which is all what? That is rational number here. We have one more example here, minus 3 by 8 plus 5 by 12. Again 8 and 12, which is a different number. What we have to do? We have to take the LCM. So LCM for 8 and 12, again as we know that we have to take smallest short division, smallest prime number, which is 2. And since here 8 and 12, which is even number, obviously it comes from the 2 here. Sorry. Now 2 4s are 8, 2 6s are 12. Now 2 2s are 4, 2 3s are 6. So still we are having 2. Let me take a 2. 2 1s are 2, 3 as it is. Now only be left with a 3. Now let me take 3. 1 as it is, 3 1s are 3. Now 3 2s are 6, 6 2s are 12, 12 2s are 24. So for 8 and 12 we got the LCM, that is 24. Okay, now 8 how much is a 24? 8 3s are. Now 12 2s are 24. Okay, see here. Now 3 3s are 9. But here minus it is minus. Minus into plus minus. Now plus as it is, 5 2s are 10. Now see here, minus and plus. What we have to do? We have to do subtraction. So after subtraction I will get 1 and the bigger number carries positive. Now let it be as it is, now 24. So for this, the rational number we got, that is 1 by 24. Okay, now from this we have one statement that it says, according to the closure property, according to this closure property, if an A and B, if A by B and C by T are the D are the two rational numbers, then their addition, when we will do addition, is the rational number. According to these all examples, we comes to know that, as you can see here, minus 3 by 8 and 5 by 12, which is the two rational numbers. And when we will do the addition, we are going to get answer, which is also what? Rational number. So from this we can say that, we say that set of rational number, as you can see, this is a set of rational number. It is also, we can say that is closed for a addition. Okay. Okay, now look at the next property, that is commutativity property. So the addition of any two rational number is said to be commutative. Okay, so when see here, according to the commutative property of addition, if these are the two rational numbers, they have how they are written. First they are added like this, and in the next word there it is, which is equals to, when we can change the places of the rational number. Now let's start with this example. So example is minus 7 by 12 and 5 by 10. Sorry, 5 by 8. So let me take again 12 and 8's LCM. Now see here, 2 6 are 12, 2 4 are 8. Now 2 3 are 6, 2 2 are 4. Now 2 3 as it is, 2 1s are. Now what we left? We left with only 3. Now 3 1s are 3 1 as it is. Now 3 2s are 6, 6 2s are 12, 12 2s are 24. So since for 12 and 8 we got the LCM, that is 24. Let me write here. Now here, see here. Now 12 2s are 24, 8 3s are 24. 7 into 2, 14, minus plus minus plus as it is 5 3s are 15. So when I do the subtraction, I'll get what is that 14 minus 14 plus 15. What we have to do? Obviously we have to do subtraction. So from this we got that is 1 by 24. Okay. Now according to the commutativity, what we can do? We will change the places. So in place of minus 7 by 12, I'm just writing 5 by 8 plus now minus 7 by 12. Okay. Now again for 8 and 12, I'll get the LCM as it is 24. Now see here, 8 3s are 24, 12 2s are 24, 5 3s are 8, 7 2s are 14. But here it is minus, minus plus is what? Minus. Sorry, 5 3s are 15 this is. Okay, now again do the subtraction. 15 minus 14 is what we will get. That is 1 only, not 24 as it is. Yes, from this we can say that both answers we got the same. Okay, that is only says the commutativity of this property. Okay, if you change the rational numbers places, still we are going to get the same answer. That is also what? Rational number here. Third property, that is associativity property. So the addition of rational number is what said to be associative when, according to the associative property, addition, if there are here it is a 3 rational numbers, they are arranged in this form. See, look at this. They a by b, which is kept it outside, and they first added c by d plus e by f. Okay, in the next, which is equals to, first we have added these two, then whatever the answers we will get, that answer we are going to add with this third rational number. Okay, now let me take this example and we will confirm. Okay, so as you can see here, 2 by 3, I'm just writing it outside, plus I'm placing minus 5 by 6 plus 7 by 12 in the bracket, and they're saying which is equals to, now I'm just writing these two rational number in the bracket, that is 2 by 3 plus minus 5 by 6. Now 7 by 12 I'm just writing outside, that is 7 by 12 here. Now according to this, as we know that first bracket problem, what we have to do? We have to solve. Now 2 by 3 plus as it is 6 and 12, what the LCM I'll get? That is, let me check it here, 6 and 12. Now 2 3s are 6, 2 6s are 12. Now 2 3 as it is, 2 3s are 6, 3 1s are 1s are. So from this 3 2s are 6, 6 2s are 12. So for 6 and 12 we got the LCM, that is 12. Okay, now see here, 6 2s are 12, 12 1s are 12, 5 2s are 10, it is minus, plus 7 1s are 7. Now let me write in the bracket until we simplify. Now here again 3 6, what we have to do? We have to take the LCM. For that 3 comma 6. Now 2 3 as it is, 2 3s are 6. Now 3 1s are 3 1s are. So 3 2s are 6. So for this LCM we got 6. Okay, now see here, 3 2s are 6, 6 1s are 6, 2 2s are 4, 5 1s are 5. Now see here, minus and 1 which is having plus, minus plus minus, further minus plus minus. Now let me write it is in the bracket. Now plus 7 by 12 as it is. Now see here, as I told you, first we have to simplify bracket, question. Okay, 2 by 3. Now see here, minus 10 plus 7, what we have to do? We have to do obviously subtraction. So after subtraction I'll get 3, but here it is what? Minus, carrying bigger number which is carrying what? Minus. So let me write for minus by 12. Now this plus as it is. Now which is equals to, again 4 minus 5, what I'll get? Minus 1 by 6 plus 7 by 12. Okay, now see here, again 3 and 12, for that again we have to take the LCM, 3 and 12. Now see here, 2 3 as it is, 2 6s are 12, 2 3 as it is, 2 3s are 6. Now 3 1s are 1s are. From this 6 3 2s are 6, 6 2s are 12. For this LCM we got 12. Now see here, 3 4s are 12, 12 1s are 12, 4 2s are 8, 3 minus 3 into 1 I'll get minus 3, and further minus plus I'll get minus. So it is 3 minus 3. Now see here, 6 and 12 LCM, let me take here. 2 3s are 6, 2 6s are 12. Further 3 as it is, 2 3s are 6. Now let me take 3 1s are 1s are. 3 2s are 6, 6 2s are 12. 12. Now see here, 6 2s are 12, 12 into 1. 2 1s are 2, and this is minus, plus this is 7 1s are 7. Now see here, 8 minus 3 I'll get 5. 12 as it is, equal sign, minus 2 plus 7 I'll get 5 by 12. So we got the same answer. So this is what associativity property for the addition in a rational numbers. Okay. So here two more examples are there that you can try. Okay. Now the next property, that is existence of additive identity of a rational numbers. So what it says, let's check. Now additive identity for the rational numbers is a 0. So what it says, when the additive identity is added to any rational number, that is additive added, what is that is 0. Additive identity, that is what 0. When 0 we are going to add to any rational number or any rational number is added to the additive identity, that is 0, the rational number remains same. As we know that whenever we are adding 0 to the any numbers, you can take any whole number. As we know that it starts from 0, 1, 2, 3. Okay, if you are adding 0 plus 3, we are going to get 3 only. Okay, so if you are adding 0 to any integers, let me 0 minus 1, we are going to get again minus 1. So similarly, if you are adding 0 in a rational number, we are saying for that is additive identity. Okay, if you're adding 0 to, for example, 3 by 2 plus 0, you're going to get 3 by 2 only answer. Okay, that only they are saying here. Okay, so as you can see, 0 plus a rational number, the same rational number plus 0, the rational number itself, number only we are going to get. So here it has been said, consider rational number that is a by b. Then when we will add a by b plus 0, we are going to get a by b only the answer. Of if you change the places, okay, then still we are going to get the same answer. The rational number 0 is called the identity element for a addition of a rational number. So this kind of question they may ask in the MCQs questions. Okay, here are some examples has been given that you can just read and check it out. Okay, the last property, existence of additive inverse of a rational numbers. What it says, the negative of a rational number is called its a additive inverse. For example, the additive inverse of a 3 by 5. Here it is 3 by 5 is what? Positive sign. So we are just changing to the opposite sign. So minus 3 by 5 is what? Now this is additive inverse of this rational number. The additive inverse of minus 5 by 8. Here it is minus. At opposite sign, what is that? That is plus. 5 by 8 is what? Now additive inverse of minus 5 by 8. So the sum of rational numbers and its additive inverse is equals to additive identity. What it says, the sum of rational number, as you can see here, minus 5 by 8 is what? Rational number, and its additive, what is that? Plus 5 by 8. So when I'm adding, we are going to get as a 0, that is additive identity. As you can see in this example, 3 by 5 plus, when we are sum is what? We are adding what? Rational number and its additive inverse. What is its additive inverse? What is that? We are going to get in the opposite sign, that is minus 3 by 5. So here my plus 3 5 and minus 3 5 get cancels. What we got? That is 0. That is nothing but additive identity. Similarly, they have done for all these three examples.